Hi there, my name's Amy Thompson. I'm from the University of Southampton and I'm going to talk a little bit today about scientific realism and anti-realism. So the question we're interested in is whether or not science can tell us what the world is really like. And in particular, we're going to focus on whether or not science can tell us about the existence of things that science talks about but that we can't see. So things like quarks and electrons and DNA and magnetic fields. Can science tell us whether or not those things really exist? So, what we're interested in looking at is this question of scientific realism versus scientific anti-realism. So, what is scientific realism? Well, science, according to the scientific realist, aims to give us a literally true account of the world. So, what we mean by that is that the scientific method is basically correct. So the way that we go about doing science is basically the right way to find out what the world is like. Scientific theories are at least approximately true, which is to say that our best current theories about the world, in particular the scientific aspects of the world, are more or less true, correct. And as I mentioned before, that theoretical entities like quarks and so on really exist. Okay, so before we start talking about scientific realism specifically, I think it might be helpful to think a little bit about what realism is in general. So, metaphysical realism is the view that there is a mind-independent world out there that we at least sometimes say true things about. So another way that we might describe this is it's the view that what we might think of as the external world, the world outside our heads, exists, and it is the way that it is completely independently of how we think or talk about it. So scientific realists think that things like electrons and quarks and so on are part of this mind-independent world. So there's this world that exists out there independently of what we think and say about it, and that unobservable entities, things that we can't see, like electrons and quarks, are part of that mind-independent world. So that means that even if there was nobody around to do scientific theorizing, those things would still exist. So now, of course, there's this big question: how can we know that things like unobservables, electrons, quarks, and so on exist? And that is a big question that scientific realists are compelled to think about. Okay. So now I'm going to talk briefly about what's probably considered the most successful, the most influential and important argument for scientific realism. So this argument is called the no miracles argument, and it goes like this. So it's an argument based on inference to the best explanation. So inference to the best explanation is the idea that when we've got a set of different candidate explanations, the explanation that looks like the best one is the one that's most likely to be true. Okay, so the no miracles argument says first that our best science, so whatever our best scientific theory is very good at making successful predictions. The second premise says that the best explanation of this kind of success, so here's the inference to the best explanation premise, is that our scientific methods are accurate, our theories are true, and that the entities that those theories describe really exist. And the thought is that anything else, so any other explanation for the success of science, would make that success kind of miraculous. It would just be this kind of extremely unlikely coincidence if it were the case that our theories were successful at making predictions and so on, and yet the reason for that success wasn't that the methods are accurate, the theories are true, and that the entities that our best theories describe really exist. And so the conclusion of this argument is that scientific realism is true. So very briefly, let's talk about some kind of responses that you might give to this kind of argument. So a first response is to say, well, look, the reason that our best scientific theories are successful doesn't have anything to do with truth and so on and so forth. It's just that if the theories weren't successful, we'd throw them out. So we're only interested in the theories that, at a bare minimum, are predictively successful. Any theories that are unsuccessful in that way are just not going to survive as theories. So people who adopt this kind of view think of scientific realism, thing that we have to argue for over and above this kind of minimum fact of success. So one way to think about this is that the way that scientific theories evolve is a bit like the way that creatures evolve. So only the successfully well-adapted creatures are able to survive. Similarly, only the successful well-adapted theories are able to survive. So it's not enough that a theory is successful to think that it's true and its methods are reliable and successful and that the entities that it says exist really exist. Another kind of worry that you might have about the no miracles argument is that it seems kind of circular. So this is a little bit complicated, but the idea is that if we want to argue for the existence of unobservable entities like quarks and so on the basis of this kind of inference to the best explanation that we've been talking about, which works for scientific realism in general, then we've got a little bit of circularity going on, because part of the idea of scientific realism in general is that these unobservable entities exist. The no miracles argument gets used in two ways. It gets used first in order to argue that in particular cases it would be a miracle if this theory was successful and yet the entities that it talks about don't really exist. And it's also used in a more general way to argue for realism about science as a whole. And the worry is that we get this kind of circularity if we want to appeal to realism about science as a whole in order to justify believing in the existence of particular unobservable entities. Another worry is that there might be loads and loads of theories that are empirically equivalent, that fit with the empirical data that we've got, and that make successful predictions, but nevertheless are ontologically incompatible. So they might appeal to various different kinds of unobservable entities, but still predict the same results. So we can imagine just kind of making up theories that appeal to different kinds of unobservable entities, but nevertheless have the same results. So, for example, instead of having a theory that appeals to quarks and electrons, you might have a theory that has tiny little leprechauns doing all of the relevant work, but your theory would still have the same predictive outcomes. Now, that's a bit of a silly example. No one really thinks that tiny little leprechauns could do the work, but in principle, there's no reason that you couldn't have ontologically different theories that have the same kinds of outcomes. Finally, you might think that the best explanation that we have is just the best of a bad lot. So maybe none of our current best scientific theories are correct, because the alternatives that we've selected those theories from are all wrong. And it looks as though thinking that we can appeal to arguments based on inferences to the best explanation is mistaken, because it might be that the explanation that we end up with, so the best theory, is indeed the best among the candidates that we've got, but that none of our candidates is in fact any good. And so again, that looks like a reason to doubt the success of the no miracles argument for scientific realism. Okay, now I'd like to talk a little bit more about explanation. So we've been talking loosely about this notion of explanation that's really important to science, and now I'd like to say a little bit more about that specifically. So, explanation is a really key concept in science. So as we've seen, it works in inference to the best explanation in the no miracles argument for scientific realism. It works in the kind of more local version of the no miracles argument for specific unobservable entities. And it also works when we want to give local explanations as part of particular scientific theories. So when we want to explain one thing in terms of another in a particular scientific theory, we're appealing to explanation. And as part of the debate about scientific realism versus anti-realism, there's a question about how we should think about explanation, whether or not we should be realists about explanation itself. So realists about explanation think that a more explanatory theory is more likely to be true. They think that explanatory virtue is tied to truth. But we don't have to think that. So anti-realists tend to think of explanatory virtues, which are things like simplicity, or the way in which explanations fit together, or how attractive they seem to us, are just pragmatic virtues. So those select the explanations that are the best for us. And what that means is that they select the explanations which might make things easier for us to understand, for example. But of course, creatures that are different from us might have a different sense of which explanations would be best for them. And if that's right, then it would be strange to think that explanation is tied to objective truth, because different creatures find different things explanatorily successful, which, if realism were true, would suggest that different things are true for different kinds of creatures, and that kind of relativism about truth is starkly in contrast to what the realist wants to say. So explanation, if you have an anti-realist take on it, isn't useful in indicating scientific realism. Okay, so let's now have a little look at the main alternative to realism. So we'll look at scientific anti-realism, and we'll look at the main argument for scientific anti-realism, as well as looking at one version of scientific anti-realism. Okay, so scientific anti-realists reject scientific realism. That's a kind of a very quick way of thinking about scientific anti-realism. And there are lots of different kinds of anti-realism. I just want to focus on one of them now today. So before we get to that, I want to talk about one of the main arguments for scientific anti-realism, which is called pessimistic meta-induction. Okay, so we talked earlier about the no miracles argument for scientific realism. This pessimistic meta-induction is like the converse of that argument. So what it says is that what's considered our best scientific theory changes over time. So hundreds of years ago, we had a very different idea about what was the best scientific theory. Theories we previously considered successful have now been abandoned, and in particular, theoretical entities that we used to think were significant, so think about things like phlogiston, have now been abandoned. Phlogiston was a substance that people used to think was released into the air when things combusted. It was later replaced with the theory of oxidation. So, given that we used to have theories that were considered successful, and now those theories have been shown to be false and to commit us to entities that we no longer believe exist, why should we think that our best current theories are going to fare any better? Why should we think that our current theories now aren't going to be superseded by better theories in the future? So let's look briefly at a couple of responses to the pessimistic meta-induction. So one way that philosophers have responded to this kind of argument is to make it clear that they don't say that our best current theories are precisely true, but rather that they're just approximately true. And so that allows for a little bit of wiggle room. So it's okay if our theories are later refined and they still say kind of roughly the same thing, but some of the details are kind of yet to be ironed out. Of course, the problem with this is that it's hard to say exactly how we should define this notion of approximate truth, but I'm not going to get into that now. Another way that scientific realists have responded is to say that we should restrict the no miracles argument to mature theories. So mature theories are those that demonstrate success by other kinds of measures, so that they cohere with other areas of intellectual study, other sciences and so on, that they have entrenched basic principles, so things that it looks like we're not going to be willing to give up on, and so on and so forth. Finally, you might say that the only theories that we should, the only entities that we should come to believe in and the basis of the no miracles argument are those that are parts of theories that have novel predictive success. So that is to say, they make new predictions and those predictions are later shown to be correct. Now, there are all sorts of problems, first defining novel predictive success, and secondly, in thinking that it should be a criteria for use in the no miracles argument. But again, I'm going to set that aside for now because I want to get on to talking about one kind of version of scientific anti-realism. Okay, so what I want to talk about now is constructive empiricism. So constructive empiricism is a view that is usually associated with a philosopher called Bas van Frassen, who argues that scientific statements don't aim at truth. So what he thinks is that rather than thinking that accepting a scientific theory means committing to thinking that it's true, which is what a scientific realist would say, he says that accepting a scientific theory is just committing to working as if the theory was true. Accepting the theory entails just believing that it is empirically adequate. And what he means by that is that we believe in the observable phenomena that the theory predicts are true. And believing in the observable phenomena that a theory predicts are true says nothing about what we should say about the unobservable phenomena that the theory talks about. So we don't need to believe anything that the theory says about theoretical entities. Van Frassen thinks that we should adopt a kind of agnosticism about those theoretical entities. We don't say whether they exist or they don't exist because that's just not really what our theory is about. All we're doing is working as though the theory were true, as though those things exist. So let's talk briefly about some objections to Bas van Frassen's view. Firstly, it requires a kind of ad hoc and a vague distinction between observable and theoretical phenomena. And there's loads of literature on how to try to make this distinction and whether the distinction stands up, which is really interesting kind of debate, but again, we can't get into it now. Another kind of objection says that arguments for inference to the best explanation are arguments against constructive empiricism because they're arguments for realism. And Van Frassen has lots of objections to inference to the best explanation, to arguments that use inference to the best explanation. And so this is part of the broader debate about whether explanation should be thought of as a kind of realist thing or an anti-realist thing, should be viewed in a realist or an anti-realist way. A final objection is just that realism seems like the common sense position. So for comparison, think about external world skepticism, the view that says that we can't be sure whether there really is an external world, a world outside of your head. Now, it's actually really hard to argue against the external world skeptics. It's really hard to come up with an argument that shows that the external world really does exist. But that doesn't really seem to suggest that we should be external world skeptics, right? Most of us are happy still thinking that there is a world outside our heads, even if we can't give kind of really great knockdown arguments against external world skepticism. Now, similarly, the scientific realist can say, look, even if I can't give knockdown arguments against constructive empiricism, realism is just a common sense view. It would just be kind of crazy to think that we're doing science and the point of science is not to try to find out what the world is really like. So it looks like we come down to a kind of stalemate there because, of course, Van Frassen is not going to accept that. Okay. Let me finish by talking very briefly about a view that takes a kind of midway position between scientific realism and scientific anti-realism. And this is a position called structural realism. Okay, so according to structural realists, we can combine the best bits of both realism and anti-realism. So structural realists say, look, the pessimistic meta-induction makes a good point. So we shouldn't really believe in the content of our best current theories. We shouldn't believe that the unobservable entities that they commit us to necessarily really exist, because it has been shown that we've had successful theories in the past, but that the content of those theories has been false. Nevertheless, there's something to the no miracles argument. There must be something right about those kinds of theories, because otherwise it would just be a huge coincidence that they have the success that they do. And more, it seems as though what's essential to a scientific theory is its structure rather than its content. So structure is the thing that is retained across theory change. By structure, I have in mind things like the kind of formal mathematical part of a theory, and things like the relations that unobservable entities have to one another and to other observable entities. So the kind of roles that those unobservable entities play. So remember before we talked about how instead of quarks and electrons you could believe in leprechauns. Whether you believe in quarks and electrons or you believe in leprechauns, it looks as though the role that those things play is the same. So if we changed from a theory of leprechauns to a theory of quarks and electrons, what's retained there is the role that those unobservable entities are playing in our theory. And what the structural realist does is says, well, look, that's actually really important. It looks as though the thing that is retained across theory change is these kinds of structures. And so structure is what we should be realists about, but we shouldn't be realists about the kind of content of our best current theories. So structural realism gives us a kind of a midway position between scientific realism and anti-realism, and for that reason it seems like at least an exciting avenue for future research. As it happens, structural realism is a relatively new position, so there's quite a lot still to be said about that. Okay, thanks very much for listening. If you want to find out more, you can have a look at the information on the screen next to me, send me an email, look at the website for philosophy in Southampton. Thanks very much. Bye.